In the natural world, we are used to a seemingly immutable rule: the strong hunt, the weak are prey. But with the beetle genus Epomis, that rule is completely reversed. These creatures, only 2 centimeters long, can turn amphibians such as frogs and toads, animals many times their size, into bloody feasts. What is amazing is that this does not happen by chance, but rather it is a survival strategy that has evolved in a sophisticated and effective way over thousands of generations. No longer a rare case, Epomis has been considered by scientists as a living example of the phenomenon of ecological role reversal. When the hunted becomes the hunter, an extremely rare occurrence in nature. Normally, this role reversal phenomenon is only recorded in species of similar size or when the prey has a special defensive advantage. However, Epomis is an exception. Despite being only the size of a finger joint, they are not afraid to face predators many times larger than themselves. Armed with sharp jaws, recklessness, and a hunting strategy system encoded in their genes, they can take down opponents that would otherwise have to flee. This makes Epomis no longer considered a weak insect in the food chain, but a true killer in the microscopic world where survival is everything. This phenomenon not only surprised scientists, but also raised a deeper question: is the order in nature really as stable as we think? If a small creature like Epomis can challenge the hunting instincts of larger species, how many seemingly correct rules are waiting to be broken? So the Epomis case is more than just a strange biological phenomenon. It is a powerful reminder that nature is full of exceptions, and that sometimes it is those exceptions that make the ecosystem vibrant and fierce. The Epomis beetle's hunting tactics are not only terrifying, but also an evolutionary masterpiece: sophisticated, precise, and extremely effective. Right from the larval stage, this beetle possesses the ability to manipulate the frog's hunting instincts with a dangerous trick, waving its antennae like bait. The tiny antennae, seemingly harmless, have the ability to deceive the vision and instincts of amphibians. When the frog sees that movement, it reacts as if it is seeing small prey and immediately rushes in, without knowing that it has just fallen into a deadly trap. The moment the frog opens its mouth and is about to swallow the beetle, the Epomis larva turns the situation around. It uses its sharp hooks to dive straight into the frog's lower jaw or leg and bites tightly. The Epomis jaws are designed like an anchor hook. Once deeply embedded in the opponent's flesh, no matter how much the frog jumps up or struggles, it cannot be removed. This is not simply physical strength, but an anatomical advantage optimized for a single purpose: to hang on and start the feast. After locking onto its prey, Epomis secretes powerful digestive enzymes that break down the frog's tissues and skin, causing the cuticle to rapidly disintegrate. The beetle then begins to suck out the prey's body fluids as a form of external digestion, before slowly gnawing away at the flesh. This entire process takes place while the frog is still alive, making it unable to escape its fate, no matter how hard it struggles. Epomis does not need to kill immediately. It immobilizes its prey bit by bit and then sips its meal like a calm butcher. This is not just hunting, but a true form of biological torture in the animal world. However, the horror does not stop there. If it is unlucky enough to be swallowed, the Epomis larva is not defeated. Thanks to its tough skin and ability to secrete enzymes that destroy the stomach lining, it forces the frog or toad to regurgitate it within minutes. And once it is pushed out of the devourer's body, Epomis will immediately continue the attack, even biting back on the mouth or chin, starting the hunting cycle as if it had never been interrupted. This resilience, endurance, and ability to turn the situation around at this extreme makes Epomis one of the most shocking predatory insects ever recorded. All of this not only changes the way scientists view the relationship between insects and amphibians, but also proves one thing in nature: survival intelligence is not about size or external strength, but about the ability to exploit the instincts of others to become their own fatal weaknesses. And Epomis does it with the precision of a natural-born killer. One of the most intriguing questions when studying the behavior of Epomis beetles is why haven't frogs, natural predators of insects, evolved to avoid these dangerous insects? In other animals, when faced with repeated threats, they often learn to avoid them or even develop defense mechanisms. But in the case of frogs, every instinctive response seems to be overridden by the simple lure of an Epomis larva's antenna. This isn't just an evolutionary flaw, it's a vivid example of how learning fails in the face of near-absolute mortality. According to biologist Gil Wazin, the reason frogs can't learn to avoid these insects lies in Epomis's near-perfect hunting success rate, 98%. Once a baby frog is bitten, it has little chance of surviving to learn from the experience. That is, learning, a key element in behavioral evolution, is blocked from the start. In biology, the ability to evolve avoidance behavior usually depends on at least some individuals surviving an attack. But with Epomis, the mortality rate is so high that there is no room for the evolution of avoidance. The victims simply never come back to tell the tale. In addition, the researchers point to another key factor: the frog's instinct to hunt for prey based on movement is too strong. Any small object that moves, especially in a staccato fashion like Epomis's whiskers, will immediately trigger the frog's attack reflex. This reflex has been programmed so deeply into the frog's brain over millions of years of evolution that it cannot distinguish between real and fake prey. Although Epomis's whiskers do not smell of food or give off any obvious signs of danger, the mere wiggle is enough to make the frog charge. And then they've given themselves up. Another point worth noting is the difference between species with toxic warning mechanisms and species like Epomis. For example, in fireflies, flashing light is not only to attract mates, but also to warn predators of toxicity. Species like bats have learned to avoid fireflies through experience of eating and being poisoned. But Epomis emits no warning signals, has no bright colors, no distinctive smell, meaning predators like frogs have no clue to be on the lookout for. The danger of Epomis is completely hidden under its normal camouflage and only revealed when it's too late. So, it's not that frogs don't have a reason to avoid these bugs. It's that they never had the chance to survive to learn to avoid them. And even if they did, their powerful hunting instincts and innate visual reflexes would make any chance of evolving defensive behavior impossible. This is the vicious biological cycle that Epomis has exploited to its full advantage, outwitting their rivals' ancient instincts, which cannot be changed in just a few generations, to maintain a near-absolute hunting advantage. Once again, nature has shown that sometimes cleverness and ruthlessness are the most powerful weapons in the fight for survival. In nature, the phenomenon of the weak turning into predators is rare, but not without precedent. The Epomis beetle is just one of several notable examples that show that the ecological order is not fixed, and that any species can upset the food chain with the right strategy. Another notable example was recorded in 2011 when Professor Shinya from Kyoto University, Japan, unexpectedly recorded a water strider, an insect, hunting and eating a baby turtle. The scene shocked the scientific community because it completely defied conventional ecological logic, where turtles are usually considered a higher link in the food chain than insects. The event quickly spread throughout the Japanese and international media, raising a big question: how many small creatures are we misjudging their survival potential? This shows that body size does not always correlate with ecological status. In fact, smallness can sometimes be a tactical advantage, allowing an organism to approach its prey more easily, to be harder to detect, and to exploit the natural vulnerabilities of its enemies. Another classic example occurred in 1988 on Marcus Island, South Africa, when the population of sea snails suddenly increased and threatened the ecological balance. Researchers decided to bring about 1,000 lobsters, the snails' natural predators, from a nearby island to control the situation. However, the unthinkable happened. Instead of being destroyed, the snails gathered in groups, surrounded, and ate the lobsters. Within a week, all 1,000 lobsters were killed and digested. This is not only a failed ecological experiment, but also a vivid demonstration of the possibility of role reversal in the ecosystem, where the hunted can suddenly become a threat if conditions are favorable. That image, if compared from a human perspective, is no different from the deer joining forces and attacking the wolf pack to survive. Although it seems absurd in nature, nothing is impossible. A seemingly balanced ecosystem can be disrupted by just a small change in the population or behavior of a single species. And when that happens, we see clearly that the true nature of nature is not a static order, but a dynamic network constantly adjusting to harsh conditions of existence. Such cases not only surprise scientists, but also force people to rethink how to intervene in nature. Every living thing is a link in a complex chain, and even a small change can cause an unpredictable domino effect. Small, seemingly weak creatures can become the determining factor in the fate of an entire ecosystem. That is why, in nature, there is no such thing as the eternally strong or the eternally weak. Only those creatures that know how to adapt in time and dare to reverse their fate are the ones that survive in the long term. Nature has never been a predictable stage. What we consider rules are sometimes just illusions, broken by the smallest creatures like Epomis or seemingly harmless snails. Through each story, we realize that life does not follow a pattern, but is a series of relentless struggles, where the weak can still become killers and the strong can become victims. That is the cold but fascinating beauty of the wild world. If you find this topic interesting, leave a comment to share your thoughts. How many other creatures do you think are silently disrupting the ecological order that humans have never known? Don't forget to follow the channel so you don't miss out on strange and surprising discoveries from the natural world.